Welcome to Mr. Math Academy. Grow your math
Welcome
brain.
back to Mr. Math Academy. So here in this video we'll go for the what is the invertible matrix. In the previous video we have done the what are the some different elementary operations like a transformation of a matrix here. Now we'll just study what is the invertible matrix here. So what it says means, suppose if I am taking the element that is a matrix A and the matrix B, that is a two matrix I am considering, that is A and B. If suppose the order is same for both A and B, in such case if suppose I am taking the matrix A into B, if I am getting the identity matrix of the same order, so that in that case I can write this as like a product of AB is equal to I. In a similar way, even if you take the multiplication like product of this B into A, then also I can, if I get the same identity matrix, so such that I can write this as, if suppose I am considering like this, if okay, I'll take like this, let A and B, let A and B are two square matrix, let A and B are the two square matrices of order same order. I can take same order here, same order M, okay, same order M, such that I can take such that the product of matrix A into B is equal to, again if I take the product of B into A, that is equal to, if I am getting the identity matrix of the same order. In such case then I can write this matrix B as inverse of A, then I can represent this matrix B, then matrix B is called as, then matrix B is called as inverse of A, inverse of A, and I can represent this, that is inverse B, like okay, and I can represent this, and it is denoted by A inverse, like A to the power minus 1, okay, means what, that matrix B I can represent as a inverse, because this matrix B is called as a inverse of A, so such that that inverse can be represented by A to the power minus 1, okay. But the thing is, and the matrix A is called as a invertible, A is said to be a invertible, okay. Now we just go through here. So what I am having, so I am having a matrix A and the matrix B. For both the matrix A and matrix B, we are having the same order. If I take the product of A into B, and again if I take the product of B into A, in both the cases if I am getting the same identity matrix I, in such case this matrix B is inverse of A, okay. Or I can take in this reverse also, this matrix A is inverse of B, okay. Now this is the somewhat we have taken here. For example, how to, okay, with the help of example we just look into this. If suppose I am having a matrix A is equal to like 4, 5, okay, 3 and 4, this is a matrix A what I am considering here. There is one more matrix which is of a same order here, because this is a 2 cross 2 order matrix what I am considering. Now if I consider the matrix B is also the same order here, I will take like this 4 minus 5 minus 3 and 4. So this is also a 2 cross 2 matrix. Now what I will do here, I will take the product of this A into B, first case. Second case is what, I will take the product of B into A, because the placement of the matrix during the multiplication plays an important role, okay. Now I will consider A into B. I will consider the product of this A into B here. So if I calculate this, this is the row here, this is 4, 5, so this is 3, 4, this is 4 is there, minus 5, minus 3 and 4. So already we know the product multiplication of the matrices here. So we will be getting here, this is, we have to take row into column like this. The first term 4 4 are 16, here we can take, so this is minus 15 will be there, because we have to multiply 5 into with minus 5. So this will be the first place. The second thing is what, this is a 4 into minus 5 is 20, plus 5 into 4 is 20 here, plus 20. So again we have to take the second row and again we have to multiply with the columns of the second matrix. So this become a 3 4s are 12 minus 12 here it is there. So again 3 5s are 15 with minus, so 4 plus 4 4s are 16. So now this is what we are getting here. Now if I just simplify, what I am getting here is, so this is 1 0 0 1. So this is nothing but the matrix I, that is identity matrix I here. So when I take the product of this one A into B, similarly I will calculate the B into A, because we have to take in a reverse order also. I will consider B into A. So I will write the matrix B here. So this is 4 minus 5 minus 3 4 here. So the matrix A is 4 5 3 4. Again we just multiply here, the product multiplication. So this is 4 4s are 16 minus 15. So this is 4 5s are 20 and again 5 into minus 4 is minus 20. So this become minus 3 into 4 is minus 12. So plus 4 into 3 is plus 12. So again minus 3 into 5 is minus 15 plus 16. So again if you just simplify this, what I am getting here is 1 0 0 1. So that is also a matrix identity matrix I. So means what, in both the cases, even if you take the A into B, even if you B into A, if I take, what I am getting, the matrix identity matrix I, which is of a same order. So now if we are getting such kind of matrices here, what we can take, this matrix B is inverse of A. So means what, so if suppose if I take like this AB is equal to I. So what we have proved here with this, so this matrix B I can take this as inverse of A. Okay, now this B entire thing I take it as A inverse. Similarly for this case, so this matrix A is inverse of B. So if I take like this, B into A is equal to I means, so this I can write it as B inverse with B is equal to I. So with this we can prove that, so AB is equal to BA is equal to I. Now this is what the invertible matrix is, and there will be a relation between the inverse of a matrix unit.